Okay, so today it's a little warm up, but the lesson we're going to be teaching is solving logs. Right now I'd like you to just try these 4 questions, and I'll hit pause while you work on the first couple, and then we'll jump in. One more thing, notice that they say either calc or no calc next to them. Like number 1, I know you could do that on a calculator, but you need to be able to do it without a calculator. Number 2, you'll need a calc. Number 3 and number 4 are also no calc. So the only one you use a calc on is number 2. If you can't use a calculator on that first one, I would be inclined to just rewrite it using that property. But it'll be 5 squared with a 5 here. And then these are the same. The answer is supposed to be there. Well, that's not going to work so great. So I'm not going to try to do it that way after all. But I just want you to be thinking about that property. If you can make this base the same as that base, then the answer exponent is supposed to be up there. This kind of doesn't work so good. But I can do this equals x and then do that circle of life and say, 25 to the x equals 5. And at that point, it's fine with me if you just go, I can see x must be the square root, right? And what's the square root? 1/2. So I could just say x equals 1/2 right there. Otherwise, if you'd rather, go like this. 5 squared is the same as 25. The x equals 5. So all I did is replace 25 with 5 squared. And now that must equal, that's a 1, that. So 2x equals 1, x equals 1/2, no matter how you slice it. Okay, raise your hand if you had a half for that first one. All right, good. Moving on to the next one. This is one where, again, I'd look to see if I could make the bases the same. Log base 7 of, 7 and 36 don't have the same base. I'm going to try it a different way. So then I'm going to go 7 to the x equals 36. That is an exponential, right? It's got an x in the exponent. It only works if you can get a bases the same or use a calculator. Since I can't get the bases the same, I have to use a calculator. So I kind of wasted some time there, but I needed to figure out what other ways there were. So I just do log 36 over log 7, and I'd be done. And when you did that, what did you get? 1.84 is correct. Raise your hand if you had that one right. Okay, good. Moving on to the next one. I really like it when they're the same bases. So I'm going to try to make this be the same base. Log base 7 of 7 squared is the same as 49, right? And I'm going to make this square root or cube root thing into a 1/3. See what I did there? I rewrote 49 as 7 squared and then used the 1/3 thing. And now there is my answer. If these two bases are the same, 2, and it's a power to a power, so do I multiply them or add them, or what do? Multiply them. 2 times 1/3 is 2/3. You don't believe how many kids think that I should multiply the 2 on top and the 2 on the bottom. Don't do that. It's really 2 over 1 times 1/3. Because 2 is the same as 2 over 1, right? So when I say 2 times 1/3, it's really like saying 2 over 1 times 1/3, which makes 2 on top, 3 on the bottom. 2/3 is the answer. Okay, last one. What should I do first? Subtract 7. 2x plus 1 to the 1/4 equals 4. What should I do next? Divide by 2. X plus 1 to the 1/4 equals 2. What should I do next? Put it to the 4th. X plus 1 equals 16. What should I do next? Now, at any point, did I ever take the square root of both sides? Or the 4th root or the... No, I never did that to both sides, so I don't have to worry about plus minus coming into this one. All right, so there's a little warm-up. So today we're basically talking about solving them where there's an x right there. We've already handled it where there's an x in the base, an x in the solution. Now we have the x right there, which is in the argument. And the nice part is that those are the simplest kind. Let's look them over in specific. Again, we've already tried it where x was here. We've already solved them where x was there. Now we're going to solve it where x is in the argument. And as I mentioned before, this is the simplest or easiest kind that there is. Because if the x is here, that implies that these two are numbers. And if you do that circle of life thing and go 2 to the third is equal to x, 2 to the third equals x, then all my numbers are on one side and my variables on the other side. So it's really, really easy. Okay, so most of these are going to be just that easy. I'd like you to give this one right here a try. Write it down in your notes and then write down the answer. It'll remind you that not everything on the test we take is going to be hard. Okay, in the front row, what do I do? Two to the fifth equals x. You are correct. And what is 2 to the fifth? I think you're right. Raise your hand if you get the same thing. Okay, good. Next one. 1/2 to the sixth equals x. Well, that's just 1/2 to the sixth. That's a lot of people put 6 over 64. Right or wrong? Wrong. What should it be? 1, because 1 to the sixth is 1. 2 to the sixth is 64. Answer 1/64. All right, moving on down. This one, we take that to the that equals that. 2/5 to the -2 equals 1 over x. Now, once you solve this, which you've just learned how to do in the last month here, you're going to have an equation that's something you learned in 6th grade to solve, but you might have forgotten. So go ahead and write down what you get in the red circle, and then write equals 1 over x. We'll see if you recognize it. Okay, so when you do the squaring part of this, it becomes 4 over 25. And then the negative makes it flip, 25 over 4 equals 1 over x. You remember what that's called? Starts with a P. Nobody remembers the name. It's okay. A lot of times you forget the name. Maybe, who knows what to do, at least. Cross multiply is correct. That's called a proportion. Does that ring a bell? A proportion. And so cross multiply to solve it. At least you knew that. So 25x equals 1 times 4. And so x equals 4/25. If I asked you for that as a decimal, you could change it to hundredths pretty easy, right? How many hundredths would that be? And times by 4 on the top and the bottom would be 16 hundredths. So 0.16. All right, next try number 4, and notice it says in red here calc on number 4. So you'll want your calculator for this one. If you haven't already, get that out. Okay, so if you know what 2 to the 4th is easy. That one's 16. But what's 5 to the 4th? 625. So if you didn't know that, maybe you'd need a calculator. But 16 over 625 is it. This is one of those classic ones where x is in the argument. That means these two are just numbers. So that means when you set it up, you got all your work done. You just got to do that one thing, 2/5 to the 4th, and you'll have your answer. So 16/25. The next one, it's 4/49 to the x is equal to 2/7. Remember, when you have an x in the exponent, what's that called again? X in the exponent is called a what? Exponential. And that means the only way you can solve those is if you can make the bases the same.